Hello guys, in this video I'll be talking about how to find the domain of a rational function. Now here it's one thing to know about rational function is that anytime you have the ratio of a polynomial, let's say in this case n of x over another polynomial, so the ratio of two polynomials, so you have n of x over d of x, for example. Now, this would be a rational function, okay? And one thing to remember is that d of x in this case here cannot be 0 because you cannot divide by 0, okay? And this is key, a very important thing to know when you're about to find the domain of such functions, okay? So having that in mind, if you have a function like this, f of x equals to x plus 4 over 2x squared minus 11x plus 5, if you have something like this and you need to find the domain, one thing to remember here is that the domain is defined as all the input values, and by input values I mean the x values. If you think of the coordinate plane like this here, x value and y values. So you're talking about the input values, the x values, for which a y value would still exist, okay? So the domain would contain all the x values for which a y value exists. You can actually find an x value a y value when you input the x value, okay? So any value of x for which this would not work, this function I'm saying, would not be part of the domain. So having said that, you guys, one thing you need to know now is that, hey, if a value will make the denominator 0, then that would be not acceptable because we don't want the denominator to be 0. It cannot be 0, right? So therefore, anytime you have a rational function, in order for you to find the domain, you just need to set the denominator to 0. Okay, set denominator to 0, not equal 0, because you don't want it to be 0. And this is solved just like a regular equation, okay? So in this case, we have 2x squared minus 11x plus 5 equals 0. I'm going to set it as equals 0 because I need to solve for those x values that will make it 0, so I could reject them, okay? Now we learned in another video, I taught you guys how to factor such trinomials. You can use the AC method if you want. Now, according to the AC method, you will have to multiply the a value, which is 2 times 5, which is the c. That will give you 10. Okay, then you break 10 down into two factors that you could use to replace 11, okay? And as you can see, to get 11, as you can see, that would be 1 and 10, right? Because 1 plus 10 will give you 11, all right? And with that, you can go ahead and rewrite the equation you had as 2x squared. I'll put 2x squared here. Then I'm gonna change negative 11 to negative 1x minus 10x, because this is the 1 and the 10 here. That will give me the negative 11 when I add them. So it's as if I'm replacing, and that's exactly what I'm doing, replacing a negative 11x by negative 1x minus 10x plus 5. Then from here, I can actually factor by grouping. And by grouping, what I mean is that you can see I have two groups here. This is one group, this is another group. So I can factor the GCF here out, in this case x, right? So if I factor x out, In this case, there's a GCF that's -5. Factor it out as well. Okay, once I do that, what I'll have inside, again, if you don't remember how to factor by grouping, I have a video for that. You can always go back to it. So this would be 2x minus 1, right? 2x minus 1 because I factor x out. And right here, I factor -5 out. So this would be positive 2x. And since I factor -5 out, this will become a -1. Because when you multiply -1 by -5, you'll get +5. So you can always double check your stuff. Okay, in this case, remember what I'm doing, by the way. It was an equation, so this is set to 0 because I'm solving. Now I can factor out the GCF. So 2x minus 1 and x minus 5 would be another factor equals to 0. Okay? Now from here, all we gotta do is going back to, let me see if I have enough space here. Let me go back up here. I have to set because again, it's a quadratic equation. So if you have two factors equal 0 when you multiply them, so that means one of the factors has to be 0. So 2x minus 1 equals 0, or the other factor, x minus 5 equals 0, one or the other, right? Then you solve them separately, and here, 2x equals to 1, then x will be half because you divide both sides by 2. In this case, x is just 5, okay? Since you add 5 to both sides. So you have these two values. These are the values you will reject, the restricted values, right? Restricted values. Okay? So those are the restricted values. So these are the values you don't want to have, because if x is 1/2, if x is 5, when you plug it into the denominator here, it will make it 0 because that's what you have as the equation. Will make it 0. But remember, since you're trying to find the domain, you want to reject the values that will make the denominator 0. So you need to reject 1/2 and 5. That means what? If you reject 1/2 and 5, that means you accepting all other values in the real number system, right? So let me make a number line to make sure you see what I'm saying here. Imagine you have 1/2 here, okay? And you have 5 here. And you're trying to reject those two values to positive infinity right here. You're trying to reject those two values, right? So rejecting this value would mean you accept the other values on the number line, right? Meaning that you would accept values here, values here, values here, but you just reject those values. Okay, you just reject these two values, right? Therefore, the domain in this case would be, the domain and interval notation would be, let me see where I can put it. Okay, I can put it right here. So the domain would be, okay, starting from negative infinity to 1/2. Now you're rejecting 1/2, so I'm gonna have to use parentheses because I'm rejecting it. Union, I'm gonna take this part too, so from 1/2 to 5, I rejected it, so I'm gonna have to use parentheses. Union again, from 5 to positive infinity. Okay, that's it. So this is the domain. This is what you do when you're about to find the domain of a rational function. Okay. Now let's quickly see another example here. Okay. Let's quickly see another example. because I want to show you another example here. Now, what if we had x over x squared plus 4? In this case, again, the denominator, you set it to 0. So it will be x to the 4th plus 4, x to the 2nd plus 4 equals 0. And you're going to solve this to reject those values because you don't want it to be 0, okay? So x squared plus 4, set it to 0 so you can solve normally. Now, obviously, guys, you know you won't get real numbers here because this is not factorable. You cannot factor it. And even if you had moved the 4 to the other side, like this right here, x would be equal to plus or minus the square root of negative 4. Now, in this case here, this is not a real number. Not a real number. What does that mean? That means you cannot find a real number to reject because you're trying to find values to reject from the number line. So if you cannot find a real number here to reject, that means if you're on the number line here, remember it starts from negative infinity to positive infinity, you have nothing to reject. Therefore, what is the domain? The domain is all real numbers. It starts from negative infinity to positive infinity. All real numbers. There's nothing to reject, okay? Because you can't solve for x to get a real number. This will give you an imaginary number, but not a real number, okay? So that's it. This is one example, but let me show you another example. Another example here, and I just want to make sure you this makes sense to you. Another example is, let's say you have, let me keep using green here. Let's say you have x squared plus 7x, x squared plus 7x plus 13, okay, over 4. In this case here, guys, same thing happened. Now, you know that the denominator cannot be 0. So you're trying to look for values of x that will make the denominator 0. Guess what? The denominator is actually a constant. It's a number 4. So it will never be 0. Therefore, for any value of x here, the denominator will stay as 4 because there's no x there. You cannot replace it by 0. You cannot solve for x. There's nothing you can do. You cannot even say 4 equals 0 by setting the denominator like that. This is not true. This is false. So you can't do anything here. You see the denominator as positive 4. It's a constant. It's not 0, so it will never be 0. Therefore, the domain again is all real numbers because there's no x to reject. So the domain is all real numbers. All real numbers. Okay? All right? So this is it. This is how you find the domain of rational functions.